Hi everyone, we're going to graph log base 1/2 of x. It's a parent function. The first thing you have to do first is do a table of values for its inverse, which I did right here. And then you're going to switch the x and the y's to get your log with the base of 1/2. So, and then we have to, so we already did this is your table of values here. This is your function. This would be your inverse because we're going to have to graph that as well. We already graphed this in a previous video, so basically we're just kind of doubling up on the work here. So I'm going to graph this. 2 goes to -1, 1 goes to 0, and 1/2 goes to 1. So basically 2, so 2, so if we type in -1, we get 2, 0 goes to 1, 1 goes to 1/2. So basically, I switched the x and y's, and then I'm going to graph this. So 2 goes to -1. All right. 1 goes to 0. And what else do we have? 1/2 goes to 1. All right. This is a little different than the other one, so it goes like this. All right. And that's your function. Okay, so it does have a 0 at 1, 0. The domain is like all logs. X is greater than 0. And our range is like all logs for the parent function. Y is all real numbers. Okay, there is, where is it increasing? So we want to know where y is increasing. Y is increasing here. From 0, you're looking at the x right here. It's increasing from 0 to 1. It's decreasing from 1 to infinity, because you're looking at your x values. Now for end behavior, we're looking at what's going on at the end here. As f of x approaches infinity, that means your x here is approaching 0. And as your f of x, which is this part in here, as it goes to negative infinity, your x approaches infinity. Okay? There's no symmetry here, therefore it's neither even nor odd. It is a one-to-one function, so we do have the inverse. And of course the inverse is just y equals 1/2 to the x. Not squared, but to the x. So I'm going to graph that one. That one, 1/2 to the x. Remember, if you look at your table, it's this one. -1 goes to 2. It's right here. -1 goes to 2, 0 goes to 1, and 1 goes to 1/2. So let's graph that. -1 goes to 2, 0 goes to 1, and 1 goes to 1/2. So it's like this. All right? So that's your inverse. That's your inverse, which is y equals 2 to the x. And I'll go ahead and graph the other one. We have it goes here, and the other one goes more like this. All right? And so it reflects over the y equals x axis. So you could fold this up and it should match. I'm sorry about the graphs, but it's really hard to graph on here. All right, so that's your inverse, and now we need to do the general form. We have y equals log base of 1/2 of x minus h plus k. And I'll go ahead and graph it here. So basically it was something like this. That's your original. And let's go ahead and shift this to the right this time. We'll shift it to the right by, say, 3. That means before we had a vertical asymptote at x equals 0. Now we're going to have it at 3. So 1, 2, 3. So now our horizontal asymptote also changed to x equals 3. And then you just kind of graph it from here. I'll do that in green. So we just shifted the whole thing to the right by 3. That means the domain changed where x is greater than 3. And now let's go ahead and shift it up. No, let's shift it down. Let's shift it down. Alright, let's shift it down by 3. No, why did I put plus? So let's shift it down by 3. Remember, you have to be careful with logs. And when you're doing horizontal shifts, you need to use parentheses. So I'm just taking my original function here and going down by 3. 3. It has the same domain. So it's just kind of like this. And I shifted it down by 3. And that's all of this one. Thank you and have a nice day. Bye-bye.